Okay, hi and welcome to Notes 5.2, which is titled Relations and Functions, but really we're going to get into some other stuff here. We're also going to talk about domain and range quite a bit, and in doing that, we have to talk about interval notation. So this is a loaded section of notes, so let's get right down to it. The first thing we want to do is ask ourselves, what is a function? We should think of a function of something similar to this. Obviously, lots of different versions, but y equals 2x plus 4 would be an example of what we know a function to be. We know, hopefully so far, maybe we're introduced, maybe we're not. We put things in x, and then we calculate for y, and we figure out what comes out. But that understanding only goes so far, and really domain and range can be lost in there. So let's take a look at a different example and see if we can understand better what a function actually is. So what we're going to do is a quick little example here about a vending machine. The vending machine itself, let's say for this particular example, before we get to the directions, and we'll talk about that. The vending machine itself, so I'm going to outline the vending machine so that you actually, that should probably include those buttons over on the side, right? That would be part of the vending machine. There's the actual vending machine. So this big blue box is the vending machine. That's the function, okay? The whole thing is the function. All right, so now that we understand that that's what we're going to represent with a function, so that we can better understand y equals 2x plus 4. There are two parts to a vending machine. First part is the button sequence, right? And this button sequence here is allowing us to put some values in, specifically like right here, A1, A2, A3, to get out a particular snack, the snack being the other part of the vending machine. So this is part 1, which is the button input, and then the output, which is the snack. Okay, so let's talk about this particular vending machine. Let's keep those two terms in mind. I'll actually write that here. I wrote opposite. So this would be 2, which is the output, and 1, which is the input. Okay, so there's my input. Sorry, I'll finish that circle. So the way a vending machine works is I go up there, I put my money in. Let's pretend that my money's already in this vending machine, and then I go ahead and I look at the keypad and I decide what particular snack I want to get out. Now we can fill this with whatever we want, and if we were in class, we'd all choose and vote to what to put in here. So I put some stuff in here: nacho cheese Doritos, pretzels, barbecue chips, M&Ms, and some Starburst. So pretty standard looking vending machine. So I walk up, put my money in, and I've got this keypad. I want nacho cheese Doritos. So to get nacho cheese Doritos, I'm going to press A1. Why am I pressing A1? Because it matches the particular snack that I want out. So if I press A1, my input, right, I get out my output, which is nacho cheese Doritos. I get exactly what I expect. I don't press A1 and then get a Starburst. That's B3. I don't press want nacho cheese Doritos and press A1 and get out A3, because that's A3. So this input picks out exactly one output of the specific snack that I'm looking for. That's what a function is. A function is where you put in an input and you get exactly the output that you expect. Not a surprise, not a variety. You're like, well, why would you get a variety? Well, let's look at this and say, let's answer some questions kind of on this idea. So and I wrote this on the side, so we'll go back to it over here. Again, I just want to reiterate, the buttons are the input. And what we're going to learn then for our function, if we go back up here and look at this function, our inputs are going to be our x values. Okay, so that's the input, that's the x value. So when I look at this function here, I'm going to put things in for x. What am I going to put in for x? I don't know, probably other numbers. I don't care what numbers they happen to be, whatever ones I'm asked to put in or whatever ones I want to find. So I'm going to take those values and I'm going to put them in for x. And then I get different values of y out, right? Other numbers, I'd assume, right? Whatever they happen to be. They don't have to be fractions. It can be any number that you want to that comes out. It's a specific value. I get one particular value out. If I switch the number that I put in, I should get a different number out. I should never really get the same one, right? If I put 2 in here, 2 times 2 is 4. 4 plus 4 is 8. If I put 2 in, am I ever going to get anything besides 8? No, I'm not, unless it's not a function. So to define itself as a function, if I put a specific input, button combination, right? If I put some specific button combination, I'm getting exactly and specifically one snack out. We will run into other things that will put something in, but we may not get the same value out. That is then what we call a relation. So function is a proper one-to-one function. I put one thing in, I get exactly one thing out. A relation, on the other hand, you may get repeated values, which we will call a bad vending machine. Why are we going to call a relation a bad vending machine? Because would you go back to the vending machine if I pressed A1 and I got pretzels? You didn't want pretzels. You wanted nacho cheese Doritos. You didn't want pretzels. So you probably wouldn't go back to that vending machine. It'd be a terrible vending machine if you never knew what you're going to get out. Unless, I guess, you were looking for a surprise. So if you're looking for a surprise, great. Then you found the vending machine for you. But for the rest of us, that's not going to work so well. So let's answer some questions then on this vending machine and see if we can better understand what a function is by using it. So will an input, a button, right? So will an input have more than one output? Again, in regards to our function, an output being a snack. Nope, every item should have one button combination. But you're like, wait a minute, Mr. Hallam, wasn't there two M&Ms? You're correct. Let's change our color here and talk about that. You can have a vending machine kick out the same snack twice, which is the exact opposite of what this question says. Will it ever have more than one output? But this is specific to one input. If you go back and look at this machine then, this is one input, B1. There just happens to be a second input that produces the same snack, or M&Ms in this case. So if I press B1 and B2, I get the same snack. But those are two different inputs, okay? So let's go back and answer some more questions. So, will an output ever have more than one input? Yeah, that's what we were just talking about. There could be two choices in the same one here, or two different inputs, okay, that would give us the same snack. We'll put that same snack. That's okay. That's still a function. But if we put something in and we get something we don't expect, that's not a function. Bad vending machine, okay? So what variable, is that right? Yep, what variable in math represents the input? Well, that's the x value or independent variable. And then what variable represents the output? Well, that's the y or the dependent variable. And we'll talk more about those two terms. And we'll have to set the tone for them in the next coming sections of notes. So don't freak out about those. If you're familiar with them, great. If not, just to reiterate, our inputs are our buttons and our outputs are our snacks. All right, so let's go down here. What occurs if there are two outputs for one input? That's that bad vending machine, right? Not a function, but a relation. Okay, so if I put something in and I don't get what I expect, I get that bad vending machine. That's going to mean that it's a relation, not a function. So there's check off the first part of our notes. So let's get some other information here so we can talk about domain and range and some general vocab here, some stuff that you need to be aware of. So a relation then is, by math terms, leaving the vending machine at this point, is a set of ordered pairs. Well, what's an ordered pair? It's a set of x and y coordinates. What does that mean? It's any x, y coordinates, right? Because x, y coordinates mean that I find a point on a graph, and that's what these are, points. You can write that down. These are points, essentially. That's what we say in class a lot, but we'll call them ordered pairs or coordinate points. All right, so then what's a function then if we just defined a relation? It's any set of points, right? That's what we're just saying a relation is. So what is a function? So a function is a relation that assigns exactly one variable in the range, so one y value, to each value in the domain, or x input, okay? So it's one-to-one. It has exactly one output. It may be repeated by another input, but it has exactly, every time I put something in, I get exactly what I expect out. Okay, so now let's talk about domain and range. So you can see up here, I think I said it right here, yep, you can see that we use the term range with y and we use domain with the x values. And that's essentially what it is. Domain is a kind of a fancy way to talk about specifically the x values. So in this, when we look at these, it's the first coordinates, obviously, also known as x values or independent variables. When we talk about domain, though, we're usually talking about more than one. Sometimes it's one, sometimes it's none, but in general, we're talking about all the possible x values that are going to be put in. So these are all the values that could be put into our function. Okay, so and I did the dots there to represent a whole bunch of different values. Okay, range on the other hand is the same thing except for it's all the outputs. So it's all the second values, or y values are referred to as dependent variables, but it's going to be all the outputs that come out. And y values are gauged by the y-axis, which are vertical. So whereas the domains are all the possible inputs that come in, but go into it horizontally, left to right, range are all the possible values that come out of it vertically, up and down. Okay, you can see I wrote that right there. All right, so because now we've kind of defined domains being left and right and range being vertical, as in values that go in and out, we have a test to verify if a function, or I'm sorry, we have a test to verify if a relation is a function. And this one's visual, okay? You can use your eyeball on it. There's my eyeball. There's the lashes. It's a scary eyeball, I know. It's a visual test, which means that you do it on a graph. Okay, and I'll show you how to do it if you're not on a graph. All right, so this test then is used to verify that every relation is a function, because in math and algebra, the only ones that we really want to talk about are functions. Relations, because they're not predictable, aren't as useful to us, so we don't talk as much about them. So what we do want to talk about is mainly functions. To do that, we're going to use the vertical line test. Vertical line test, I'll show you in the examples. Okay, so right now you just know that if I draw a vertical line through any graph, right, through any one point on the domain, that it only touches exactly one point, that it won't touch it twice. And I'll show you that in the example. It'll make a lot of sense. All right, so let's talk about a specific type of function, which is a discrete function. There's also a continuous function, so you'll notice there's two main types that we're going to talk about. A discrete function, then, is one that has a finite number of domains. What does that mean? That means that there are ones that you can count. There's not an infinite amount, okay? You can count these particular domains. So an example would be a set of points. So if we look at these 2 points here, point 1, 2, right? Here's your x value, here's your y value, here's your x value, here's your y value. The domains for this is 1 and 3. That would be a discrete function. Well, I'm sorry, using domain, we shouldn't talk domain. We're talking discrete. I can see 2 points. There's only 2 points. I can count them. Okay, let's talk about a continuous function. Then a continuous function is that there's a whole bunch of points, more than one. You can't count them. There's an infinite number of points. Okay, so for that, it's going to look like a line or some type of a graph visually. It's a whole line because let me change my color here real quick. I can put points on here. I can count these points, but are those all the points that make up the line? Is there points between those, and isn't there points between them? So a continuous function is a set of points that touch end to end forever in an infinite amount of points. Whereas you can see with the discrete, there's just a couple of points. Yeah, maybe there's more than a few, but you can count them. That's the key thing here, that you can count those points. All right, so let's get down to set notation. Set notation is how we like to identify domains and ranges. So when we talk about domains, sometimes we'll put a D, and then we're going to use these, what we call set notation. They're called the fancy brackets. They're little squiggles. So I do like an S, and then I do like a 2, and then I do a 2, and then I do an S. And then we write all the values in between. So if it's discrete, we would write all the different numbers in parentheses in there, and that would say, hey, these are all your x values for your relation or function, okay? But we've got this continuous function, which goes on forever. And I don't know about you, but I really don't want to write an infinite amount of points inside of those fancy brackets. So that's not something we can work with. So for interval notation, we have to use inequalities. And I don't know if you can see this here. I'll blow this up a little bit. We get to use inequalities for interval notation. So in interval notation, you're going to start and say, inequality, I guess, let's start by defining what an inequality is. Isn't it a range of points, right? We say the low end, right? Low end, and we say the upper end, and then we use an inequality to say it's everything in between there, okay? That's what this x represents. This x right here represents all of the possible domains. And so then what we're going to do next, let me just switch my color here. What we're going to do next is pick the lowest value that it could be that exists on the left and the highest value that it could be on the right. And that's what we're saying. So we're saying all the values are going to range between the lowest value and the upper value, and it's every possible point inside all the infinite number of points that exist there. Oops, wrong button. Okay, so that's what this interval notation is going to look like. We also have a fancy way of doing it without the actual inequality. We can do it with just parentheses. So before we do that, though, let's talk about the difference between open and closed, and then I'll show you how to do the one without the actual inequality part. So this one's called an inequality interval notation. So these are inequality interval notations. We'll talk about the bracket version in a second. So the difference between open and closed, right, would be our dots. So if the dots are solid, that would be closed. If they're open, they're open. What does that mean? this means that that boundary is included. Okay. If it's open, it means it's not included. It means it's really, really close to this point right here, but it's not that point. Not that point, or not included, if you will. Okay. Should be somewhat familiar with that, but if it's open, like this one, it will not include the equal sign underneath. If it's closed, if that point is included, it will have the equal sign underneath. So that should set us up for interval notation. Real quick, let me just show you the bracket version of it over here. So this would be what it would look like for open and closed brackets. You can see some various forms of it. Here are the intervals. What this means is for us, if the point A is included in the solution, right here, closed, if it's included, it'll have a square bracket. If it's not included in the solution, it'll have a rounded bracket. So, and you can have one side included, like half open one here, and one side not included. Okay, and so that's the general idea of what these brackets are. And so the brackets are doing these by these shapes, rounded and squared. You're doing the inequality part of included or not included. So can you have that to infinity? Yep, you can have that go on to infinity, right? There's just one side of the bracket that's open that goes to infinity. So that's just a quick review. You can look that back over, but let's get down to a couple quick examples, and then we're almost done. So this question asks us to find the domain and range of the snack machine. Is the relation defined by the snack machine, vending machine, sorry, an example of a function? Well, it is actually an example of a function. We're going to jump back there. Every snack in here has exactly one input, right? Every button combination, A1, goes to exactly one snack. So that would be an example of a function. Okay, it's not just a relation. So let's look at the next example. It says, give the domain and range of each discrete relation. We don't know that it's a function at this point. Then decide if each of the following relations is a function. So we're going to first identify the domain and range. So identify the domain, you put a big fancy D, right? And then you do your fancy squiggles, and then you list all of the first coordinates, or x values. Okay, so by listing all of those, we're going to write 1, 3, 5. You do not repeat domains or ranges in that case when you're writing them in set notation. Do not repeat them. So if you see it more than once, you don't write it. In this case, they didn't happen, but I'm just saying. You'll see it in the next example. All right, so then the range for this would be all of the y coordinates or second values. So you just put r, colon, fancy brackets, 2, 4, and 6, because those are all your second values. So we've identified the domain and range for a discrete relation. Now what we're going to do is we're going to see if each one of these goes to exactly the same value, or to one specific value, and that they don't go to something else. And you'll notice that that works here. So real quickly on the second example, if I input 1, just to show you what a relation is that's not a function, 1 goes to 2 if I input that. So this would be like putting A1, I get Doritos. But look at, if I put A1 in here, I'm getting Snickers. If I put A1 in again, I'm getting 4. So each time that I put this value of 1 in, I'm getting a surprise each time out for my output. So that's not a function, that's a relation. All right, we're going to pause there and we'll pick up the rest of the examples in class. All right, have a good day. We'll see you.